Thanks. Thanks, guys, from the Amazon team. That was awesome. I've been looking forward to your talk because when the dataset first came out, as Jimmy mentioned, we kind of like were eager to like just put it into 51 and kind of look at it, and we did a little blog on it, which Jimmy can share. But I just wanted to show kind of like we had ingested some of the components of the ARMBench dataset into 51, and I just wanted to show people really quick like what that kind of looks like as just to kind of get a feel for I guess both the data set and then also our tool 51. So if you're not familiar with 51, right, Voxel 51 has this open source data management, curation, and visualization tool. That is 51. That's what you're looking at. And like I said, we had ingested a bunch of these data sets, and it's really cool. And so I just wanted to like really quickly do a little lightning flash session and show off like what some of the things you can look at in this data set. So I'll just start with the defect one. This is the one we blogged about, and also you guys had ended on it, so maybe like there's some continuity. You can see here, so this is our data set, your data set, I should say. And you can see here, this says, this is ingested as what we call a grouped data set in 51, because there are like 4 cameras. So like a lot of computer vision data has like multiple views, right? Like you might imagine stereo vision or something, something where you have multiple sensors. So in the defect set, right, guys, you guys had like 4 cameras, I believe, and they were like registered, right? So it was like capturing the transfer process from different angles. So in 51, we call this a grouped data set with different slices. And so we have like camera 1, camera 2, and so on. And then there's 4 views for any particular object. And for the label type, you can see this color kind of looks like a brown box or something. That's actually like a segmentation. 51 covers like it includes like every label type you've ever heard of probably. And so there's a lot of options. If you have segmentations, right, the GT annotations here, I've ingested them as like polylines. You can also do bit masks and so on. So that's our label. And you can see, you can zoom in on the object, kind of get a good look if you like. That's kind of what that guy looks like. So that is the group data set. And as you can see, we can scroll through, we can select our different views. This has like you guys were saying, it's got like 40,000 groups, right? And then 4 views. So it's like you said, over 100,000 images. So that's kind of the label, and you can kind of see the images and the labels. What's really cool, right, is like you can see the metadata, right, which is really interesting in this data set. I've ingested these into 51 as what we call tags, which is pretty much what you think, kind of like free-form labels, right? So like you guys are saying, there's a lot of nominal images, right, which are like the normal case of like everything's going well. The fun cases, right, are the not nominal cases. So I can easily filter, right, if in the sidebar, if I just select open book jacket, it'll just immediately filter down to those interesting defect cases. And it says, there's 680, right? So, okay, like what's going on? I can make this actually bigger to make this easier to see. And I'll turn off these segmentations, and you can see, right, it's exactly like what you guys were showing, right? I imagine this sort of, whenever I see this, because we've all had this experience of the book opening in your hand, right? I just feel like with actuators, this must happen like anytime a book's not wrapped, right? It's just going to be highly likely to do that. And again, like if you click in, right, you can see like from all the different views, the bad things happening with this book. So that's the kind of book jacket case. And then I found a really funny case that, just like you guys were saying, I think it was in a crushed box. Like you guys pointed out, there are a lot of, in the open box and crushed box scenarios, you can capture a lot of these objects mid-flight, you know what I mean? This is the Powerade. I think in the open box defect also, there were a ton of these. You can see this, captured midstream as this stuff is falling out. So really interesting defects. I'll reset that guy. So we get a good sense of our labels, right? And then what's really cool, I want to show something with our embeddings view just to kind of take a look at what you can do with embeddings in 51. So let me go to a patch view. This is really cool. So if I click on this button, this will immediately go to what we call a patches view, which like isolates each object. So if you have some data set with detections, right, you can immediately just focus on those. And then I'll open up my embeddings pane. So 51 has like a big model zoo. You can run models out of the box. I've run models to generate feature vectors, embedding vectors for all of these objects. And you can visualize them in this plot here. This has been dimensionality reduced with UMAP to preserve like structure, And so I'll color by the label. Let me refresh the colors here because those are kind of hard to see. Should I refresh the color? Yeah, this is kind of cool. So you can see there's some structure here, and I don't know if you can see this like nub here on the bottom left. These are all the gray. The legend kind of shows you what the annotation is. And the annotation here is basically like that defect state, those tags that we ingested. So see how all the gray samples are down here, and the label says book. So those actually, we can lasso those samples, and that'll select those objects. And indeed, those are actually like way overweighted in the book defect class. You know what I mean? So it's really cool. Like the model appearance models, the embeddings have figured that out, right? Because there is a certain morphology with books that are open, right? They kind of have a certain look. So the embeddings are able to figure that out. It's really cool. I can also show there's another interesting piece up here. I think with this section, anytime there's any kind of clustering, right, in your embedding space, you might find some interesting correlations. And so here, right, these are all the models, right? So just something really cool you can do in 51 to investigate your images in feature space and pixel space. So that's in our blog. We had kind of released that earlier. I wanted to show really quick, like the segmentations as well. So we ingested a bunch of these data sets. This is the same object transfer set. And so this is really cool. Again, this was in the Cocoa format, so it was kind of like one line in 51 to ingest this guy. So super easy to ingest. And then for fun, we actually recently put the segment anything model into our model zoo. So if you guys are interested in segmentation, we just put this in. So here, we have an extensive model zoo in 51, and here you can see the SAM model, small, medium, large. If you've never run 51, it is like super easy. So this is like literally what I did. I said load the model SAM, the B, the base size, and then this will run the inference and compute the segmentations. That's it. Once I did that, you can see this SAM guide. Let me change this color actually, because make it a little easier to see. And so now we've got our ground truth and our SAM. Now I should flag this. I did prompt the SAM. If you're familiar with SAM, you can prompt it. I did prompt it with the GT boxes, so it's not a totally realistic test, right? But I just kind of wanted to give a flavor of comparing segmentation. So you can see now, dig in, you can see the ground truth, you can see the SAM model. You see the SAM doesn't do a great job on this one, right? Because it's got missing the lids here, or I'm sorry, it's missing the lids, whereas the ground truth has got it right. I ran evaluations. 51 has a great evaluation library, so you can find all the misses, right? So I've run an evaluation library. After I do that, I have a count of like how many missed segmentations I've got in each sample. And so I've set like an IOU threshold, and then I've basically compared like the masks, you know what I mean? So this evaluation routine will go for each object and say, hey, how well did you overlap with ground truth? And you can see here that, I don't know if you can see that, but it says false positive because it didn't overlap well enough. Same for this guy. So this lets you just browse right through your data. This number here is showing like how well your SAM did. So 0 means it didn't make any errors relative to some threshold. But I can filter and say, hey, you know what? I want to find out where my model didn't do so well, and then dig in, and again, it's like what the team said, right? It's very interesting. You can dig into these cases. Translucent packaging is a common offender, right? If you've got overlapping objects, that makes it hard for SAM to get it right. There's one with the sides versus the tops. That's another one, right? So here's the ground truth, and here's you can see how the SAM model is missing the sides of the bottles, So anyway, just a really quick flavor of, are we able to visualize a concrete score for each object along with the labels? Yeah, you are. Let me see. This one, I don't know if the SAM prediction came with the count. That's a good point, actually. So normally when you run a model out of the box in the 51, it will populate confidence. I'm not sure. I don't see it here with the SAM model. So maybe, I'm not sure if we populated that in our zoo or not. That's a great point. Actually, if you're following along at home, we actually just recently fixed a bug in the SAM. So when you run the SAM, be careful, get the latest version. I'm not sure yet. Usually with the detection models, you will see a confidence score here. I'm not sure why with the SAM, maybe it's not in our integration yet, but great question. I will get out of the way. I don't want to take a long time. Just the flavor, so please try this home. Actually, if you ever go to our try.51.ai, this is our public deployment. I actually put like a tiny, like 100 sample data set on there if you want to click around and kind of take a look. Thanks again to the Amazon team, and thank you very much. This was great. Really enjoyed your talk.